Hello, this is Joe Doer again. I'm back with, I'm going to start on a new project today. It's a little different. It involves both the lathe and the CNC router. You could do the whole project on the lathe, but I'm going to do it on the CNC router so I can give you guys a little, some experience with how you use a CNC router. I did a little bit of an overview in my shop tour, but this is going to get into more of the considerations you have as far as bit choice and down spiral, up spiral, all that kind of stuff. Anyway, the project we're doing is out of this magazine, this latest issue of Woodcraft magazine. It's the October-November issue, number 19 for 2023. And what the project we're going to do is it's called an inside-out cake stand. I thought it looked pretty cool. Let me see if I can open to the right page here. Okay, so you can see this here, but the interesting thing about this cake stand is this post here. If you can see it, it's actually hollow, and both the inside and the outside are turned. So I thought that was pretty clever. Now, what he's using, the wood he's using in this example is padauk, which is a beautiful wood when it's first done. It has this iridescent orange color, which is just spectacular. The only thing I don't like about padauk is that over time, it darkens considerably and turns almost brown. It still doesn't look bad, it just doesn't have that iridescent orange color anymore. So what I'm going to do is I'm going to use Bubinga for two reasons. One, I really like working with it. It's an incredibly dense hardwood, and it finishes really well. Plus, the last bowl I made, I like the best of all the bowls I've made, and this will match it. So this is the bowl that I made out of Bubinga. It's a combination of a closed segment and open segment design, but it's really, I just love the Bubinga. It really holds a nice finish. So I'm going to use this wood instead of padauk, but you can use any hardwood for this project. So I've already dimensioned the hardwood. So this is a piece of Bubinga that's going to be used for the top. It's 3/4 of an inch thick by almost 11.5 inches square. This is going to be the base, which is about 6.5 inches square. It will eventually be round, of course. And I've dimensioned the wood for the center post. Now, the way this thing is made is 4 pieces, 1.5 inch squares, okay, and 7.5 inches long. And so you put it together as you would want the end finished product, the grain going in the way you want it on the outside. But we're first going to turn the inside, and the way you do that is you make this pattern on the ends, and what we're going to do is we're going to rotate each of these pieces 180 degrees first. We're going to hold them together with double-sided tape and strapping tape, and we're going to turn and finish the inside first. Then we're going to take that off, break it apart from the double-sided tape, rotate it back to this. Now this symbol that we've drawn here is so that we can get each piece back in the same orientation that we started with, because with this particular design here, there's only one way of getting that design back to the way it was, which will ensure that we don't have a piece that's out of order. So that's what we're going to do. Now, you could do, as I said, you can do the this whole thing on the lathe, and that's fine. But I wanted to use this opportunity to show what's possible with the CNC router, and so I'm kind of stretching it. You don't really need to use a CNC router for this, but I thought it would be an interesting thing to show everyone how a double-sided project works. So we're going to have two double-sided projects, one for the top and one for the bottom. And the bottom, actually, we're going to end up turning after we do what we're going to do with the CNC router. We're going to end up turning it anyway to get the final shape, the outside shape. The inside shape is what I want to use the CNC router for, and I want to sign my name in the bottom, all that good stuff. I'm going to do it with the CNC router. But the outside shape, I want to be able to do on the lathe, mainly because I want to get practice. I've mentioned before that I'm not a super experienced with a lathe. I still consider myself, either a novice or barely intermediate as far as skill level on the lathe. But so I'm going to be doing the outside of the base, on the lathe. So, all right. What else can I tell you about this? So, let me put this away. We're going to be holding. We're going to be holding all this stuff down for the CNC router with double-sided tape, and the reason for that is because they're not big enough. These items are not big enough to really hold well. So if I turn the vacuum on right now, I can move this, and I can move this, because there's not enough surface area for the vacuum to hold it. By the way, I had, in my shop tour, I had talked about this vacuum table, but there's one thing I don't think I mentioned, which is, if you look at this thing, there are no holes for the air to come through, and the reason for that is this is made out of 3 layers of 3/4 inch MDF, and actually the top 2 layers are made of something called ultralight MDF, which you can't get in every lumber yard. You have to go to a specialty lumber yard for it. But it weighs about 40% less than MDF, for one thing, and it's also more porous. They use less resin in it. So even normal MDF is porous. Like if I try to put a piece of MDF on here, it's not going to hold no matter what, even if it was the entire size of this thing, because the air flows right through it. The other thing is that the top and bottom layer of an MDF has more resin in it than the bottom. So if you remove that like 1/100th of an inch from the top and the bottom, air will flow through it. So basically the air is flowing right through this thing, and I've had to seal up the edges so I don't lose suction on the edges. So what we're going to do, one thing I could do is I could remove this vacuum hold down and use clamps. But the problem with that is, first of all, this thing is heavy. Removing it and putting it back on is not a fun chore. So what I'm going to do instead is take a piece of scrap plywood and put it on here, and this will be held on with vacuum. Now, you cannot move that. There's no way you're going to move that. What's happening is that what's holding this thing down is not the vacuum, It's actually the atmospheric pressure on top of it, right? So atmospheric pressure at sea level is 14.7 pounds per square inch. So this is 24 by 36, which is about, I don't know, 700 or 800 cubic inches, and you multiply that by 14. So you're looking at, if it was a perfect vacuum, which it's not, it would be about 9,000 pounds of pressure. It's the equivalent of having 9,000 pounds sitting on this thing. Now, it's not a perfect vacuum, so maybe it's 5,000, but whatever it is, you ain't moving it. So what we're going to do is we're going to take some double-sided tape and basically attach this to the with double-sided tape to here. We're going to cut one side. I'm going to cut registration holes in the corners so that when I flip it over, I can then drill registration holes, the same registration holes in here, in this sacrificial piece, flip it over, and use little pegs so I can register it exactly. So the top and bottom are registered precisely. And then I'll cut the other side. So that's how you do double-sided work with a CNC router. Okay, all right, let me get set up and I'll come back when I'm just about ready to run the tool paths and give an explanation. Okay, I'm back. I mounted the piece that we're going to use for the top of the cake stand with double-sided tape to the sacrificial piece of plywood here. And now what I'm going to do is define where the origin point is. So I marked an X in the center of the workpiece. So I'm not going to show you the software because that's a whole thing in itself. But I'm just going to explain the concepts. If you're interested in learning how to do it in the software, I would highly recommend you go up to a website called vectric.com, VECTRIC, and I think they probably have a trial on. I would download their VCarve desktop program, or at least the tutorial videos, and that'll show you, explain some of the concepts and show you how to set them up. But at a high level, what you're doing when you're designing the tool paths is you're telling the software that you've got a piece that's, in this case, almost 12 inches square, it's 3/4 of an inch thick, and you're telling it to base all of the tool paths off of a specific origin point. And the choices you have are, as far as the vertical, you can either register off the material surface, which is what I'm doing here, or the machine bed. You can do either one, and there's reasons for using one or the other. But I'm registering off of the material surface. You also specify where you're doing it XY as well. So you can do it in the left corner, the right corner, left bottom, right bottom, left top, right top, or the center. I almost always use the center, especially when you're doing double-sided work. It just makes things a lot easier. You don't have to worry about, is it flipped over? Everything is, the origin point is in the center of your material. So I just mark the center point, and then I'm going to bring my bit over, the first bit that I'm using, which in this case is an 1/8 inch end mill. And then I'm going to bring it down. And I'm going to get it as close as I can to that center point. It doesn't have to be exact because I make the piece is a little bit oversized. So there's going to be some some stuff left over, so it doesn't have to be exactly dead center, but I try to make it. Let's cut the X. The Y is good, so I'm going to set the XY. So that's the origin. I've set the XY origin. Now I'm going to lift it up. Now I have on this machine I have a touch-off device, which is handy. You can't use it for every bit. They're really sharp bits that can break off you don't want to use it for, but for something like this I can. And so what ends up happening is that the machine knows that the touch-off device is exactly an inch thick, so it comes down, touches the device, and now it knows that the origin point is right there on the surface of the wood. Now, the first thing I'm going to do is drill some 4 registration holes, and they're 1/4-inch holes. But I'm not using a 1/4-inch bit. I'm using an 1/8 of an inch bit, and the reason for that is that these bits can either be up spiral or down spiral. Okay, so in a normal drill bit, it's always up spiral, right? Because the spirals are designed to pull the chips as you're drilling the hole, to pull the chips out and eject them, right? So, but the problem with that is it actually exerts an upward force on the material. So that can be disastrous when you're holding something down. Right now, we're holding everything down with the vacuum. Basically, this scrap piece of plywood is being held down with a vacuum. If you have any upward force, it's extremely dangerous, because once you lose suction, you're gone, and the piece starts moving on you, and then it's ruined. So I always use down spiral bits. There's another type of bit, by the way, called a compression bit, which is kind of weird. It's got the first maybe 1/4 inch is an up spiral, and the rest of it is down spiral. And it's used, if you were in a single pass, you were going to do a cutout. It's to prevent tear out on the top and the bottom, but I never use it. I'm always using a down spiral bit, because it pushes down an ore. However, with a down spiral, if you try to drill straight into, like you would with a regular drill, there's nowhere. It's trying to push the chips downward, and there's nowhere for the chips to go, and you generate an incredible amount of heat, and it can actually start a fire if you do that. So what I'll do is, if I'm going to do a 1/4 inch hole, I'll use an 1/8 of an inch bit, and then it just kind of corkscrews, and there's room for the chips to get out of there. So that's what I'm going to be doing. So the first bit I'm using is this 1/8 of an inch bit, and it's just to drill little registration holes that when we flip this thing over later on, we can use to register it. So I'm going to leave the dust shoe off, because this doesn't create a tremendous amount of dust, and it'll show you this thing in operation. So let's see now. Now, this bit has got a sharp point on it, so I don't want to use that touch-off device to accidentally damage the bit. I would do this by hand, just a very thin piece of paper. Okay, so I've now registered that guy. I'm going to put the dust collector on, because this will probably start making some dust. All right, now we're going to run the next tool path. Now is I followed up the end mill with a bulldoze, and I'm going along the edges. It's to give a curve, so that groove that I made for the dome, it doesn't have rigid edges which can catch food in there and everything else. So this is going to give it a more gentle curve. Okay, so that's that. Now we're going to flip it over. All right, so now we have to drill registration holes in the bed, so that we can, when we flip it over, we can align it properly. So let's do that. Back to the origin. We'll put that eighth of an inch bit in here. And every time you change a bit, you have to re-register. So now we're going to register this down to the plywood. So we're drilling the same 4 registration holes we did originally. And I'll leave it open again, you'll see. Okay, so I put those 4 metal pins in those registration holes. They're just a 1/2 inch long and 1/4 inch diameter. They fit in those holes, and I've got the holes that are drilled in the top of this fork here. So when I turn this over, the origin. Couple of times. I'll come back when we're finished with this part, and we're going on to the next. Okay? Now you notice that I can take these bits right off and they're not hot. The reason is because I don't really push the envelope. I go at conservative feeds and speeds. All right, I'm going to come back after this. I'm running this at a very slow speed. I'm going to come back when the top is completely done, and then we can start on the bottom. Okay, I'm back. So I finished cutting the top and the bottom on the CNC router. I'm probably going to end up mounting it back on the lathe, these pieces, just to do some touch up. But so here's the top. There's the little Mortise in here, you know, for the stand. It's got kind of a og'd edge along there, and there's the groove for the glass dome. So I could actually just touch this up with sandpaper and I'd be done with it. I might want to do it on the lathe though. I started the base. Now I'm going to turn most of the base on the lathe, but I cut this pocket out and I signed my name in and put there. I wet it so you could see it a little better. Now, everything but the signature you could do on the lathe, and I might have been able to do the signature afterwards, although I would have a smaller base, so it might not be that stable. But anyway, I really did this this way just to give you a feel of what you can do with a CNC router and how you can integrate it with your other work. Just to give you an example, here are some of the bits that I used. So as far as end mills are concerned, I used an 1/8 of an inch end mill, a 1/4 inch end mill, and I had to use this bigger end mill. This is a 3/8 inch end mill, and the reason is because the base is 1.5 inches thick. Right, so I needed something that would cut all the way down when I did the cutout. This pocket, this curved pocket here, was made by a 1-inch bullnose, and This is a 45-degree V-bit, which actually carved the signature. And then I also have a 1/4-inch bull nose that I used for the partially I used for the dome groove. So now we're gonna start on the post between the base and the top, and so. And if you remember, we had these things rearranged where they will be in the final place, and I made that little square with the L around one edge, and then I rotated them, each piece 180 degrees, and I put them together with double-sided tape. Okay. Now, I also I'm going to wrap the other side too, but I also wrapped the ends with this strapping tape to prevent when we're turning it from a thing flying apart. So I measured 1 inch down from the top and 1 inch up from the bottom, and that's where the tape is going to go. And so we're going to carve between the tapes. I also made a mark 2.5 inches from the end right here. This is going to be the deepest part that we're going into. I think we go into, I forget what the radius is, what the diameter is, but it's in the magazine article. So that's the deepest part, and then we just come from up top here over to here, and so that's how we'll get the shape for the inside. Once we do that, we're going to sand and finish the inside completely. Then we're going to take this tape off. We're going to rotate everything back, and we're going to glue these square pieces. The 1 inch ends is the only thing that's going to get glued back together, and then we're going to turn the outside. One other thing I will mention to you is that you'll notice that in the center here I cut a little pilot hole on both sides, because when you put the spur drive in there, you don't want it splitting the pieces. Also, be careful when you put the spur drive in, not to have the teeth of the spur drive, those 4 teeth of the spur drive, going into the seams. So you want to make sure that they're between the seams, so they also don't split the side. So anyway, I'm going to go over the lathe, and I'm going to set this all up, and then I'll come back. Okay, here I am. We're set up on the lathe here. Both corners are strapped. This mark that I made, this red line, I want to get that. This is going to be my deepest point on this thing. Let me bring this down a little bit. So this is going to be my deepest point, and I'm using negative rake scrapers because I don't want it to be too aggressive. Again, I don't have the greatest technique in the world, so I want to be very careful I don't damage this thing. On this side, on the inside, but also especially when I end up doing the outside. But anyway, let's start cutting this thing. All right, rather than have you watch me do all of this stuff, I'm going to get it to the point where it's done, where I finish turning it, and then I'll come back and we'll finish it. Okay, I'm done turning this. This is going to be the inside now. So I've sanded it smooth. This is, I think, the shape that they're looking for. This distance here, this narrowest distance, is 1.5 inches. This point here is 2.5 inches from the back. So I think this is the kind of silhouette they're looking for. I might be a little off. So what I'm going to do now is I sanded this up to 1200 grit. I'm going to finish the inside of this, which will take me a couple of days because I use Danish oil and I wait 2 days between each coat. So I do 2 coats and then I polish it with a Beal buffing wheel. So after that, what I'll do is I'll come back and take these pieces apart, rotate them 90 degrees, and then glue them back together. Instead of using the pressure sensitive tape, they're going to be glued finally, and then we're going to turn the outside. And hopefully I did it correctly, and the thing doesn't blow apart on me, but we'll find out. All right, I'll see you back in. Okay, I'm back here. Just want to show you. This is the post. I put the first coat of Danish oil on here. I'll put another coat on tomorrow. And then a couple days after that, I'll polish it. And then I'll take these pieces apart and rotate each piece 180 degrees. Glue it back together. And then we can turn the outside of the pedestal. What I'm going to do now is work on putting the bottom, this bottom that I made yesterday. I want to put this on the lathe, and the way I'm going to do that is I'm going to use this center hole. So what I had done was I found this. It was just a waste block that I had on a plate here, and I used a 1-inch Forstner bit to drill a hole in it, and then I used the CNC router to cut this little ring out of 3/4 inch ply because the diameter of this is too wide. So I need to bring it out so I can get in. So what I'm going to end up doing is putting some pressure sensitive tape on here so it holds up against and it's centered properly against this guy. And then I will take my bottom and also center it against this. And I'll use pressure sensitive tape on this guy as well. And so this thing should then be centered on the lathe, and I can turn down because this is actually the top of the bottom. This is the bottom of the bottom. So this has to come in, and I didn't have enough room here. And there are screws in the in the waste block, so I couldn't take the waste block down too much. Anyway, so that's what I'm going to do. I'll get it mounted on the lathe, and then I'll come back and we can start turning the base. Okay, I've got it on the lathe now, and I'm using, if you can see it here, I'm using a jam chuck to hold it against there for more stability. But I have to tell you that the centers line up perfectly. If I turn this on now, it's almost perfectly round. It's just a little, you can feel just a little vibration, but it's nothing. It actually worked out pretty well. So the plans, here they are. The plans call for the base to be, pretty intricate as far as the bunch of OGs in here and all sorts of detail. I'm not going to do that, I don't think. I think I'm going to make it a much smoother bottom that kind of comes up and curves in because I really love this wood, and I don't think it requires, if you had a plain wood a more plain wood, walnut or maple or something like that, then I think adding the detail would be nice. But here, I think I'm going to try to keep it smooth, um, and I might come out and come in a little bit. I'll play with it a little bit, but um, yeah, I think that'll look better once it's finished because Bubinga finishes really amazingly well. So anyway, I'm not going to have you watch me do this. I just wanted to show you how I mounted this. So I can also mount the uh, uh, the top the same way because the top has that same um, Mortise hole in here, so that the post ends up going between the top and the bottom. So I could actually put this on the same way as I have that, and then do whatever with sanding or final work that I need to do on the top. I don't know if I will or if you can just do it by hand, but anyway. So I will come back, I think, um, after I have the that spindle, the center, the post, glued back up together, and we can start to turn that, and then hopefully both the base and the top will be completed, and then we can look at final assembly. But I just wanted to show you how I ended up solving the problem of remounting uh, something that you did on the CNC router. Now again, uh, all of this stuff could have been done on the lathe without the CNC router, except for the signature in the bottom. And I could have probably done the signature later if I had enough, if enough flat area here to hold it down properly. But I just wanted to give you a feel for some of the different possibilities. The CNC router is amazing. I use it all the time for doing these little things when I need to do something. Um, I come up with these ways of doing that, which you wouldn't normally do because you don't have the precision. I mean, this thing ends up making. I mean, I have the 1 inch dowel that I bought, which wasn't quite 1 inch. Um, so I didn't want to make a 1 inch hole. I ended up making a 0.99 hole, which fit perfectly. So that's the kind of stuff you can do um, that it's difficult to do any other way. So anyway, I just wanted to show you that. I will come back in a couple of days when we're further along, and then we can look at, you know, uh, turning the post, finishing everything off, and then wrapping the project up. Okay, I'm back. Okay. So far I've completely finished the bottom. This is what it looks like. So I've put 2 coats of um, Danish oil on this thing and then buffed it with the Beal buffing system. So that's done. And I also, after I finished finishing the inside of the post, I split it apart. Well, the first thing I did is I went over to, I have a 6x48 belt sander over there, and I sanded all 4 edges smooth because they were going to be on the inside. I split it apart from the double-sided tape with just a spackle knife and a rubber mallet. And then what I ended up doing is I glued 2 of the pieces back together. I reformed that symbol because they're going to go back one way. I took 2 of them together, glued 2 sets of 2. When that was dry, I also went to the belt sander and I took just a little bit off. So 180 grit sandpaper on that. Took a little bit off so that the glue joints would be solid. So now this is what I've got. I'm a little worried because the amount of wood right here is very little. So hopefully it doesn't blow apart on me. The other thing I did before I turned it is I turned it from a square into an octagonal. I had made this this jig a couple of years ago, and I use it mainly for doing pen blanks. So it's a thing that you put on a bandsaw table. The blade, there's a notch in for the blade if you're getting very close. But all you do is you set it up. You take a clamp and you hold the jig down, and then you can run this thing along the edge and basically cut off the edges so that it's just closer to a round shape, and you don't have to take as much off. And I want to be very careful with this because there's not a lot of structure left to hold it together, and it could very easily blow apart on me. So we'll find out. Anyway, so I'm going to mount it on the lathe, and then we're going to turn it. Again, both ends, I drilled pilot holes so that the spur center and this live center at the back don't split the wood, and also make sure that I'm not putting the four teeth of the spur drive on the seams. Okay, let's start to turn it now. I can put my apron on. Okay, so I've finished turning and sanding the center post. I did the profile a little bit differently than what they showed. They had a lot more detail, so I wanted to keep it simple. So what I'm going to do now is finish this. It'll take actually 4 days because I put a coat of Danish oil on. I wait 2 days, and I put another coat of Danish oil on, wait another 2 days, and then I buff it out. So in 4 days, hopefully, I'll be back, and after we've done final assembly on this guy, and I'll show what it looks like. Okay. Okay, I'm back. So I finished the final assembly on the cake stand. I'll bring you upstairs actually and show you what it came out. It came out very nicely. I'm happy about it. But before I do that, I just wanted to reiterate some of the information I told you about the bit choice here. So and explain it. So this is a standard drill bit. Okay, this is what they call an up spiral bit. So as the drill bit turns, it's forcing the chips up out of the hole. This is a down spiral. If you can see, it's just the opposite. It's going in the opposite direction. So as it turns, it's actually forcing the chips downward. And you know, I mentioned that it's dangerous, but it's amazing how little force you need. If I turn this on right now, right, I cannot move this piece. The vacuum is too much. It's thousands of pounds of force. But if I take my one finger and lift up a little bit, the whole thing comes up. That's what I'm talking about. That little bit of upward pressure can break the vacuum seal, and then you're done and you're finished. So I just want to reiterate, if you want to get into CNC routing and you're going to be using a vacuum hold down like this one, you need to use down spiral bits. If you're using clamps to hold it down, or maybe even double-sided tape, then it's not as important. But certainly for a vacuum, it's important. The other thing I wanted to mention to you is that what I'm using to power the vacuum here is a shop vac, but you can't use a standard shop vac for this. You need to get a vacuum pump, or Festool actually makes, it's a fairly expensive shop vac. But the reason you can't use a regular shop vac is that a normal, $79, $80 shop vac relies on the air flowing through it to cool the motor down, right? Well, your goal here is to get hardly any air flowing through it, right? You want to basically block off as much. If you put a 2 foot by 3 foot piece here, it's going to block off 95% of the airflow. And now, if you had a normal shop vac there, you'll burn it out fairly quickly, because a lot of times these tool paths will take, I've had tool paths that take 7 or 8 hours to run, and you'll quickly burn out a normal shop vac. So if you're going to do it, if you're going to build a vacuum hold down like this, you need to either get a specific vacuum pump and build an enclosure for it, or you can get a Festool shop vac, which has a separate fan that cools off the motor. It doesn't rely on the airflow through the vacuum. All right, so let me go upstairs and I'll show you what the end product looked like. I'm happy with the way it came out. This is what the finally came out as. This is the bowl that I had done in Bubinga, and this is the cake stand. And that center post is really, I think, pretty cool. It came out pretty nice, I think. And then here's it with the dome on top. So that's it. Let me know if you liked it. Okay, bye.